Okay, good afternoon. It's time for us to get started. So as you know already, we're gonna have our second exam on Wednesday, March the 30th. So we're gonna have on the second part of this lecture, of today's lecture, we're gonna do the review. But before we get to that point, there's material that we have to cover to complete. So we will complete this lecture on material handling equipment, which is lecture 9, which we started on Wednesday last week. And so during our discussion on Wednesday, we talk about different type of material handling equipment, and we started with the transport equipment. We discussed the cranes, the industrial trucks, and the conveyors. And as I mentioned on Wednesday, I use this picture just to illustrate the difference between those 3 categories. So cranes are used when you have or you need a variable path. And one of the disadvantages is that it has a limited or a restricted area that it can cover. So that's in the figure, you will notice that there's an area, constant color in blue, that is representing the restricted area that a crane can cover. But again, it gives you that flexibility in terms of having a variable path, so you can move things around within that restricted area. And in the line, the red line is there to illustrate the conveyors. The idea with the conveyors is you have this fixed path. So you're using, in this case, this line is representing a fixed path between 2 points. And when you use conveyors, you know that you need to have a high flow of product or items, because that's the only way that you can justify an investment of a fixed path. So high volume, and you know that these items are going to be moving from point A to point B a lot. You have a lot of units that are moving between these 2 points, so the conveyor will be an option for those cases. And then we have the industrial trucks. These are the combination of a variable path and an unrestricted area. So that is illustrated with these lines. So that area, this big area, when compared to the other 2, is represented with the lines. So a truck will give you that flexibility. You can cover much more area, and also you are not restricted with a specific path that you need to follow. So those are the main 3 categories within the transport equipment. And then after that, we transition to positioning equipment. And we talk about one in particular, one category. Let's see, 56. So we started discussing the positioning equipment, and we went through this group of positioning equipment. So we got started, and today we're going to continue this discussion. As I mentioned, we're going to complete the lecture today, this lecture today, and then we're going to transition to the review. So let's get started. Let's move to the slide that we, the last slide that we discussed. And we're gonna start from here. So use the right setting here. Okay. So positioning equipment, and now we're going to talk about unit load formation equipment, and this is used to restrict materials so that they maintain their integrity when handled as a single load during transport and storage. So easiest way to remember this is using a pallet, right? So you know you have this pallet, you're going to be putting items one on top of the other, and then you're going to form a single unit by putting those items together. And then you can move that pallet as a single unit. But that's not the only option we have. Let's talk first about the advantages. More items can be handled at the same time, and also enables the use of standardized material handling equipment. So if you are moving just one box at a time, you will need some type of material handling equipment. Maybe you can have a person moving that box, or you can move it with a cart. But if you have a single pallet, then you know that you can use one of the trucks, like a forklift, to move that pallet, and that will enables these standardized material handling equipment. So these advantages, you have to spend some time forming and breaking down the unit load. So it's not like let's say you're putting 100 boxes together. So that box that's the first one in the pallet is going to spend a lot of time waiting for this pallet to be formed. So if you're measuring the cycle time of each item, that pallet, that first box that is put into the pallet is gonna spend a long time before it's moved to the next item or to the next operation. So you also have to spend a long time putting it together and breaking it down. There's a cost associated with the materials or the containers or the pallets and other load restricted materials used for those purposes. So you have an extra cost. And empty containers pallet may need to be returned to their point of origin. So once you are done moving this load to the destination, then you know that you have that extra operation of bringing those items back to the origin so you can use them again. So those are the disadvantages. Whereas if you're just moving a box by itself, one at a time, you don't have to worry about those. So again, this is a matter of trade-off. So what will be better for the type of operation that you're trying to design for? So there's a group of formation equipment, unit load formation equipment. Those are listed here, and we're going to show some pictures, some figures associated with each type. So let's start with these three. So the slick sheets, the deck board or the pallets, and the tow pack. So all of them used very frequently. These are more common when you're moving, like moving businesses will use those a lot, but also within the company, if you need to protect the units, maybe a pallet will not be enough. So you have to provide some extra protection to those items. And you will recommend to use this type of product. Some additional, so these are a little bit bigger, the pallet boxes or skid boxes, and then the intermodal containers. So these again, larger scale, maybe you're putting the pallets inside this item, but again, still a uniformation equipment. In terms of securing these items, we can use a robotic pick and place palletizer. So you don't have the human element interfering with that process. Also, this shrink wrap, stretch wrap machine. These are common in airports. So if you go to an airport, you see sometimes they use these machines to cover the luggage. So the idea is once you have the pallet formatted, or you have the group of items together, you put this plastic around so they don't move, and you can also protect them for other things. And then the manual palletizing, this gives you to the operator some extra safety, so they don't have to move a lot. You can just use like, this is like a table. It will go up and down depending on what what you need in terms of positioning these items into the pallet. Potential reasons for storage includes these three. Time bridging allows products to be available when it's needed. For example, storing spare machine parts at the facility. So if you need to provide some preventive maintenance to your machines and so on, you have these parts there. Processing. For some products, for example, wine, storage can be considered as a processing operation because the product undergoes a required change inside that storage. And also for securing nuclear waste storage. So this is also something that is continuously being evaluated. So there's some containers that are being used for those purposes. And then once you secure them, then they're taken to a specific area where they're stored, making sure that they don't provide any risk to the safety of the people. Any questions so far? So again, this lecture is more illustrations, discussion in terms of what you can use, disadvantages about this equipment. So another list here for storage equipment. We're gonna go through those now. These are more for warehouse operations. So now we are looking at these racks that you can use not necessarily to move the items, but once you got into the warehouse, you want to place them somewhere. These are some of the options that you have available. So you have here the selective pallet rack and the drive-through rack. Their goal is the same. They're used for storage purposes. You want to place these items, you want to keep them stored for some time inside the facility. But the difference is the flexibility that they give you in terms of moving around the storage, or the warehouse. So for example, here you have an area where you can move with your transportation equipment. You have the space, and it gives you the flexibility of moving around and also placing the items as needed. The flow-through rack, this again, depending on how much space and how much material you want to put in your warehouse, maybe you don't have space to provide many aisles within the warehouse. So you need another option. So for instance, this one, the flow-through rack, this is one that you can feed the rack from the back, and then you can take the items from the front, and it gives you that movement, or not give you movement, but once you pick an item from the front, the next one will move forward. So it gives you that flexibility. Then the driving rack, again, these are some areas that are used for driving purposes, or if you want to just push some of the items into the rack, you can do that. But the idea again is the same: storage within the warehouse. Pushback rack. This one, again, if you have limited space, this one will give you the option of moving these racks back and forward. So if you need to, for example, get an item from here, you can slide this rack, and then you will have access to that line. Shelves, bins, drawers, these are more for small parts. If you want to store them safely. These storage carousel are common now in these operations like Amazon, or if you go to a supermarket warehouse like HEB, you'll have these carousels, and those are essentially there to help you put together their orders. Like if you need to put an order for a supermarket in San Marcos, they're requiring certain items, and you will use the carousel for those small items and to pick up those orders and then put them together into the pallet and send it to the supermarket. Warehouses like Amazon, that will be more into the customer. So if you are requesting 3 different products, you want to put them in the same box. These are some of the equipment that are used to help the picker, which is the operator, get the items that are needed. Some other configurations, these are larger scale. The mini-low ASRS. So same idea, you are using this automated equipment to store and to pick up some of the, in this case, boxes or items that you need from your storage. So you have these carts that will move up and down, and they will have information about where the items are located. So if you need them, you mark the code, and those will be brought to you to the receiving area. Other configurations, the spill case order picking system, and the man on board ASRS. Again, this is the same idea. Now, instead of having the robot bringing things to you, you have a staff member or an operator moving up and down, back and forth, so they get to the position where the items are, and they will grab them from the cart. So those are storage equipment. Again, these are more for designing for a warehouse, defining for a company that will need to put orders together, or a supermarket that will need to put orders together, and many other businesses. So moving forward, we have the identification and control equipment. So these are used to collect and communicate the information that is used to coordinate the flow of materials within the facility and between the facility and its suppliers and customers. So for example, barcodes, radio frequency tags, magnetic stripes, machine vision, portable data terminal, and electronic data interchange internet. So one of the most popular ones, RFID, they use some radio frequency tags, and they will keep track of the items or the product as they move through the supply chain back and forth. So always an option is to have no equipment, right? So this is the cheapest way, but maybe the more staff or human resource needed to develop. So the identification of materials and associated communication can be performed manually with no specialized equipment, although it's sometimes possible to manually coordinate the operation of material handling system. Becomes very difficult to do as the speed, size, and complexity of the system increases. So if you're managing a small warehouse, small supply chain, you might be able to do some of those tracking and order processing by hand. As the size of the business increases, you'll have to rely on more sophisticated equipment, such as the ones that we're going to talk about. So barcodes, these are also like given a name to a specific product. It could be the product, could be the position or the storage, in the storage for the product. Any different could be the expiration date, so you can have multiple information about the product associated in this barcode. To represent values of alphanumeric characters, barcode system consists of a bar label, barcode scanner, and barcode printer. For example, if you have a card, you have this number. It will be in the doors, it will be in the close to the front, and that will keep track of your card. Is in a specific number that is associated with your card, and it will have information, more information that you will think about, like where it's produced, which country, and so on. So every time you go for an inspection, it will scan that number, and they will keep track of that card. So that's an example. So barcode system consists of this barcode label, Contact barcode scanners use panel 1 to read this label. So again, you scan it, you get a lot of information about the product. And 1D codes are most common than 2D codes, which enable more storage for the data. The radio frequency tag, this is data encoded on chip encasing a tag. No contact can be read when the tag is within 30 feet of an antenna. So that's a good thing. If you're moving things fast and you don't have time to go scan the code directly, these radio frequency tags are a good option. Tags can either be attached to a container or permanently or temporarily to an item. And the RF tags have greater data storage capability than the barcode. The magnetic stripe, these are the ones that you have in your credit card or your debit card, has data encoded on a magnetic stripe and that is readable in almost any environment. But it requires contact with a reader and had greater storage capability and more expensive than the barcode. In terms of the machines, the machine vision does not require explicit encoding of data since objects can be identified by their physical appearance. So this will be more like a scanner, like the ones that you will see in the airports that will be telling you what's inside. So those are the machine visions. No contact, but typically requires structural lining and more flexible than other identification equipment, but less robust. Portable data terminal, like a handheld, arm mount, or vehicle mounted data storage and communication device. Again, these are becoming very, very common. Like, for example, if you go to a store and you don't find something or you need to get the price of an item, you can talk to a staff member that will have this handheld, that will scan it, and it will give you all the information about the product. Communicates with the host computer via a radio frequency or infrared link. Variety of input devices available, like a keyboard, barcode, scanner, and voice headset. Electronic data, interchangeable, internet, electronic. These EDI provide standards for intercorporate transfer of purchase orders, invoices, shipping notices, and other frequently used business documents. Prior to the internet, the EDI required expensive dedicated value-added networks, like VANs. That's no longer the case. EDI is critical for implementing just-in-time manufacturing. Deciding on a picking, medium, and picking operations. So these are, again, operations in which you have a big warehouse with products and you have to go and put together orders. So deciding on a picking medium in those operations. As part of warehousing operations, specifically in picking operations, identification of the parts and their locations can have an impact on the picking speed. So again, if you're in the business of making sure that the customers get the best service that they will, look for, one of the things that are used to measure service quality is time, right? So how fast can you get this order to me? So if you want to be able to provide that service to your customers, then speed is one of the items that you have to shoot for. So there's different options. Again, picking speed is important for most businesses. So the following are the most commonly used mechanisms for communicating picks to order pickers. Label picking, pick to light, radio frequency barcode picking, and voice picking. So the idea is to provide some type of guideline for the operator in order to know where it needs to stop and get the item or the product, or helping visualize where to go next if you're putting together an order for a customer. So label picking could be colors, could be numbers, could be letters. And then you have a map that is telling you have to go to red, green, yellow to put together this order. Or you have lights doing essentially the same signaling to the picker. Barcodes and voice picking, same idea. So it's guidance, voice guidance for getting the order together. Equipment selection criteria. So in order to make a decision, you have to take into account these categories and measures. So depending on the type of product that you're going to be handling, physical state, size, weight, shape, condition, risk of damage, and some of the measures that you can use to differentiate between, for example, physical state, if it is solid, liquid, or gas, the size, the volume, the length, the width, the height. So all those things will impact the decision that you are gonna make in terms of the equipment that you are going to decide to use for your process. Here's some guidelines for deciding on the transportation method. So again, we have the flow rate on the y-axis. This is the quantity of material to be moved. And then on the x-axis, we have the move distance. So how far you need to go with this product, if it's a short distance or a long distance. And you can see that I have two per axis, two differentiators here, high and low in terms of the quantity of material to be moved, and the distance, if it's a short distance or a long distance. So for example, if you are looking at having a high volume of materials to be moved, but you're moving them for a short distance, this is telling you that you should go for a conveyor. If you have a very low material to be moved in the short distance, then basically any manual operation should be enough. Manual handling or use a hand truck. You have a low material to be moved in a long distance, then you have to go for a power truck or a unit load AGV. And then in the case in which you have a high quantity of material to be moved in long distances, conveyors and AGV trains should be the options. So the highest and the longest you have to go, maybe the more money you have to spend on this material handling. And this ties back to our discussion, right? At the beginning of the semester, we were looking at this from two charts in order to measure the amount of flow between departments, right? Because we don't want to put two departments that have very high flow separate, because that's going to have an impact on the type of material handling equipment that you will use. And it's going to have an impact on how much money you need to spend, right? So conveyors are very expensive, AGVs are very expensive. So if you make a good decision in terms of putting those departments close, then you might be able to manage the material handling using less expensive options. So that's the whole idea. Okay, so you want to plan your facility well from the beginning. You want to put those departments that have a very high flow together, so you don't have to spend more on this later on. Questions? So this is the summary in terms of flow rate. This is the same information we have in the previous slide. And we talk about this, the layout type, fixed position, process, and product. So this again ties back to other discussion that we had at the beginning of the semester. So if you have a fixed position, large product size, low production rate, and then you will be using these cranes, hoists, industrial trucks to manage that design. If you have a process layout type, you have a variation in product and processing, low and medium product rates. So hand trucks, forklift trucks, AGVs. And the product design, layout type, limited product variety, high production rate, conveyors for product flow, trucks to deliver the components to the station. So again, tying this information back to our discussion at the beginning of the semester. Safety and ergonomics, so very important when you're designing your facility, when you're choosing the equipment, you have to keep in mind your staff. So you want to be mindful about designing, making sure that the staff is safe. So ergonomics and safety is always very important. So scientific research shows an increase in injuries at certain levels of exposure to heavy, frequent, and awkward lifting. So job design is very important in creating a safe and healthy work environment. And the selection of the proper material handling is very important. It can help you reduce injuries. Why is this important? In addition to provide safety to the employees, which should be very important, should be at the top of your design. In addition to that, when you look at from the cost perspective, and for the company itself, if you have employees that are injured frequently, that put an extra cost to the company because they have to pay for this health expenses and also for therapy, and they lose also that employee for amount of time. So if you design keeping your employees in mind, making sure that you provide a safe environment, healthy environment, you're also making sure that they stay in the company, they stay healthy, and they can work, which is also important from the business side. You're not keeping your employees out. You're not have to cover all these health expenses, which are a lot if you go that route. So very important. So paying attention to heavy lifting, frequent lifting, and awkward lifting is always important. If you're in an IE, I think you get a course, IE 3360, which teaches some of these concepts for ergonomics. If you're manufacturing, just keep those in mind. When you're making decisions, make sure that you involve someone that is familiar with this concept, so you also take those into account. So these are some additional measurements. The point that I'm trying to illustrate here is that this is information that is available. Like when you're designing, you're making these decisions, you don't have to guess, right? You can just go to some of the standards that are available. For example, the Department of Labor and Industries, they will have this. OSHA will be another source of information. So you don't have to try to guess, that information is already available and you can use that information. Principles for reducing heavy lifting: reduce the weight, increase the weight, use mechanical assistance, slide instead of lift, team lifting. All those are options that we can, material handling equipment, the ones that we discussed that will help you lift some of these so the employee doesn't have to move outwardly when putting together these orders and so on. Mechanical assistance, avoid unnecessary lifting and mobile storage. Removing obstacles, slide closer, reduce the shelf depth, reduce package size, use mechanical assistance, team lifting. All those are ideas. Simple, right? These are things that you will guess. I mean, you don't have to guess. You know that these are things that are safe. But when you're putting together a design, you're not seeing the people, right? You're not, if it is a new design, you don't have the ability to see how these things are working. So, so getting to at least consider these items from the beginning is important. Reducing outward lifting. There are other technologies that are being developed now, like some skeletons that are being used also if you have to, mechanical skeletons that are being used also to help lift some heavy weights. So those are getting very expensive, but if you need to make a trade-off, probably keeping the employee safe will be cheaper than just going for that equipment. So keep your employees safe. That's the message that I'm trying to give you. So principle for reducing awkward lifting, reaching above shoulders, arrange storage, use mechanical assistant, use a rolling stair or safety ladder. I'm sorry. I'll put this online after the class, so you don't get all the notes. Those are going to be available. Principle for reducing awkward lifting, twisting, use conveyors, provide more space, arrange storage. Duration is another thing. So if you have an employee that is working 8 hours lifting things, you might need to rotate that employee to other tasks during the day. So you can avoid injuries and also use mechanical assistance. So as I mentioned, for you can visit the Occupational Safety and Health Administration website. They have all this information and is already there for your use. So I always like to bring these pictures. So even if you design for a safety environment, there's always the human aspect of it. So you have to provide some supervision, keep your employees educated on the subject, and make them understand the importance of following these guidelines. Okay, so that's the last slide. Any questions? Good. So now let's talk about the exam. So second exam, March 30th, which is Wednesday. And these slides are also available now. So so this is going to be the second exam. The format of the exam will be similar to the first exam. So the exam will be online. You have an hour and 20 minutes to work with the questions. In this case, you only have 3 problems instead of 4. And then in the first part, you're going to have multiple choice true or false questions that are going to be based on the theory that we discussed in class. So I'm listing the lectures here. I decided not to include lecture 9 because I think you don't have enough time to get ready with that. It's a long lecture and the exam is in less than 48 hours. Oh, yes. So I decided not to include lecture 9. So I will go through the material, the lectures now. But again, format is similar. Best way to prepare is to go through the slides. Notes are available. Understand the concept, different concepts. Remember that you only have 1 hour and 20 minutes. So if you try to just figure it out during the exam time, it's not gonna work. Okay, so you have to prepare for the exam. The lectures that are going to be included are the following. So we start with manufacturing systems. This is lecture 4. Here we discuss fixed automation systems, flexible manufacturing systems, single-stage multi-machine systems, and also just-in-time manufacturing. So from this lecture, you need to understand the differences between these manufacturing and these systems that are listed here. And also understand what is just-in-time. Why is it relevant? Why is we always talking about this particular manufacturing strategy? How does it work? So I guess at this point of your training, you should be familiar with this. So let's go back and review what just-in-time is. Supply chain management. We talk about this. What is a supply chain management? The components of a supply chain management. What are the obstacles and common problems, and how are those associated with facilities design and facilities planning? Supply chain strategy framework. So we spent some time going over this. So again, lecture, always keep in mind our discussion, how is it connected to what we are trying to achieve when we are designing facilities. And then we transition to the design of the structure of the facility. So we talk about different things, space requirements and layout. So we discuss structural system performance, enclosure systems, atmospheric systems. So here's where we discuss how to design for the capacity of a ACE or the heater. Electrical and lighting systems. So understand the steps in getting the planning and what are the differences in this design. So if you're designing for office versus you're designing for an operation versus you're designing for a manufacturing system, what are the differences? We talk about how the requirements change, right? Because for some operations, you might need some extra lighting. For some other operations, you'll be good just with natural light. So as the operations become more detailed, or you need to put more, let's say the assembly is with small parts and so on, you need better lighting in order to make sure that you get the right assembly or design. So life safety systems, we talk about the importance of designing for against fire. So those are the things that you should remember. Personal requirements. So now from the design of the facility from the perspective of the employee. So what are the things that you have to provide to your employee or your staff when designing this facility? So we talk about the requirements in terms of restrooms, office facility planning, barrier-free compliance, and how to design for a parking lot. For example, if you need to have these many spaces and you have this area, can you come up with a design based on what we discussed in class? And then finally, we have the schedule design lecture 8. Sorry. Here we talk about the marketing information, how to compute process requirements, how to compute the number of machines that are required for a specific operation. And then also we discuss machine assignment problems. So if you have these many machines and manufacturing lines, how many employees would you assign to each of them? And those are the lectures 4 to 8. So that's why I decided not to include 9, because I thought it was going to be too much, especially since we have the exam. We're doing the discussion of the review today, and the exam is in a couple of days. So lecture 9 is not included. It's up to lecture 8. So to prepare for the exam, study the lecture slides, lab and homework, the assignments. So if you're familiar with those problems, you should be able to do very well in the mathematical part of the exam. So my advice, sit down with the assignments, the labs, make sure that you understand how to solve these problems. And then for the multiple choice true or false questions, more into understanding the discussion that we had in class and the slides that we covered in terms of concepts and so on. The exam is closed book and notes. I'll put the link to the exam in Canvas. So on Wednesday, like we did in the previous exam, you will see a module for the exam, and then the exam will open at 12:30 on Wednesday. You have until 1:50 to work on the exam, and then you have 10 minutes to upload the materials. Clearly show your work and all formulas used in your solution. This will help me award full and partial credit. So I decided to grade. I have a grader for this class for the assignments and the labs. I decided to grade the previous lab by myself, so just to get an idea of how you're working your problems. I found out that you understood the concept, but the details sometimes are not there. Like, for example, we did the problem in class, and I asked you, can tell me how many spaces you have to your design is doing. Like, after you do all these computations, tell me how many spaces. And I will say half of you forgot to do that. So read the question, make sure that you understand what the problem is asking you to do, so you work the answer to get that information there. Also, some of you were in the right direction, but then you don't show me all the details. So if you made a mistake, then there's no way for me, if you have the wrong answer, to go back and see where the problem was. So for example, students were getting 3 or 4 less spaces from the right answer. If I don't get the process there, I mean, there's no way for me to give you partial credit. I'll have to take points out because I don't have a clue of what you did. So show your work, tell me what you're doing, and then give me the right answer at the end. If you don't give me the right answer, I can see your process. I can figure out where you missed something, and then I can give you partial credit. So clearly show your work and formulas using your solution to sell me a work for partial credit. The multiple choice true or false will answer using the computer, and then 3 questions or problems that you will have to upload a file. As I mentioned in the first exam, sorry, these are not the right times. Should be 12:30. Apologize for that. Okay, so 12:30 to 1:50, bless you, and then 10 minutes to upload your fonts. You can upload all the answers into a single file. Just put them together, upload the single file, that's fine. Or if you want to separate them and put them on the separate spaces, that's okay too. Okay, so you decide how do you want to proceed. Any questions about this format? Yes, sir.
You mentioned you're going to try and get a classroom. Are we still doing this online, or are we going to do it?
Online. It's going to be online. Yes. So the exam is going to be on Canvas. I checked today, this morning. No, nothing. So we have 32 students, and I don't think we have 32 seats here. It's steady. So yeah. So we're still doing it online. If you need to have a space to work on the exam, just communicate with me and I will provide you with that space. Like, I will come here to the classroom with you guys, or I can provide you with a machine, internet access, all those things. You just have to send me an email, I will do that. Any other question?
Are you gonna publicize all the class notes today?
Yes, so the notes will be available today. I think most of them are already there. I will complete the uploading today. Question was if I'm gonna provide with the notes. So yes, answer is yes. Okay, so in terms of the problems, just want to give you an idea what you should expect in the exam. So something like this, you work on this in a lab, or not in the lab, but in the classroom, we'll work on this problem. And also we have an assignment associated with this. So if I ask you a problem like this, I'll have to provide you with the coefficients, the U coefficients for transmission of each facility component. So those will be provided, and then I'll give you the information about the facility. So you have just to follow the process of designing for either a HVAC for cooling or heating. So it will depend on the problem. So this will be a potential problem then this is what you just did for today's assignment. So again, a problem like this one will be also possible, in which I give you this information and I ask you to tell me the number of machines that will be needed for a process. So remember, you have to take into account this if defects. In this case, we have that extra information about the defects. So you need to go and compute that input that was required for the process before finding the number of machines that you needed per process. Okay, so when I'm referring to, this is something that we did in the first exam to get the input based on the defective rates, the input at the beginning of the process. So in this case, you needed the input for A1. Once you got the input for A1, A2, and ID, then you were able to figure out the number of machines that were needed per process. In this case, we have two types of machines, A and B. So when you're computing the total number of machines for A, you have to combine them because they're the same machines. Okay, so that's what we did here. And then you have to round up. So 31.57 as 32 machines, 12.79, those are 13 machines. The input at the beginning of the process becomes our quantity, QK. So once you figure out I, that will be QK. And then the rest of the process is just making sure that you use the right coefficients. So you need the standard time, you need the efficiency, the reliability to compute the number of machines. Also make sure that you use the right time units. So in this case, we have the standard time, processing time for per machine in minutes. So the time for processing also has to have a unit in minutes, so you can cancel them out. So I think that will be the major challenge. Make sure that you remember that you use the right time units when computing this information, so everything can cancel out and you get the right number. And then this is the design for a parking lot. I think this is the lab. So again, I'll give you all the information that you will need. So in terms of tables and diagrams that will be needed for you to get the right information for the design. So yes, so remember to use the to design, remember that you have to include the circulation lanes. Your design again might not be the same, right? So in this case, for this design, we use, or I use the 400 as the space for locating the perpendicular parking spaces, but you can use that 370 to do the opposite. At the end, I will know whether or not you have the right number of spaces based on their strategy that you decide to follow. So yeah, any questions? Good. I think that's the last slide. So I'll be posting this today. Still have some time, so if there's any questions. If not, then I will, again, if you need an area or space to work on the exam, let me know. I'll work with you. We can set you up here. We can set you up in my lab. I can provide you with a space if you need it. So I'll be here on Wednesday. If you need, I'll be available in Zoom. So if you need to ask me something during the exam, I'll be available. You can connect to the Zoom for the class and I'll be here. Any other questions, comments? No. So I'll see you Wednesday.